Start. It's
Okay.
4:02. Yeah,
Let's
let's.
go.
Excellent. So, welcome everyone. I really appreciate you guys coming to this talk. It's really important to know about beavers because they are going to be right alongside as we fight for dealing with issues related to climate change and drought. Beavers are going to be our partners, and so today I'm going to be talking about that. I'll start off with introducing myself, Garrett Costello with Symbiotic Restoration. I have been doing low-tech process-based restoration since 2018, and we'll talk a bit more about that. But basically, we are doing stream and meadow restoration, not using heavy equipment. We are doing everything by hand. We're using people power, hand tools. Well, we use chainsaws, and I'll get into that a little bit more. But it's a different type of restoration. It's a little bit lower impact. And it also has the lens of beaver. So we are always trying to restore a system when possible to create an environment that's healthy, that attracts beaver to come and take over as restoration practitioners. We'll get a little bit more into that soon. Just a quick thing on my background in for education. I went to Humboldt State University, now Cal Poly Humboldt, and studied environmental management and protection. And I got minors in restoration, ecological restoration, soil science, and environmental education. So kind of just a nice general background, environmental background. And then I met the right person. I was in Northeastern California, and there's a wonderful person up there called Todd Sloat. Todd Sloat with Forest Creek Restoration. He's been restoring streams and meadows for, I think, over 20 years. I may be saying that wrong. And he took me under his wing and taught me all that I know now about stream and meadow restoration, assessing these areas for health, going out and doing analysis, putting designs together, restoration design. And then I really loved the implementation piece. That's what resonated with me. I like to go out there and do the work myself. And so I started my own company in 2018, and I run crews of human beavers that are out here on the landscape restoring these meadows and trying to help bring the beaver back into these systems. With that, let's dive into the presentation. Okay, so North American beaver. I'll play a video here. So North American beaver is the largest rodent in North America. It's the third largest rodent in the world. And this is actually a juvenile beaver trying to reach for a willow. So we'll talk about kind of why they beaver and why they build dams and all of that soon. But they are keystone species. They are habitat engineers, and they create incredibly healthy wild areas for us, for wildlife. The benefits are profound, and we'll go into that here shortly. All right. Okay, so here's another shot of a beaver. They are vegetarians. So beavers are eating the cambium layer of mostly plants in the aspen family, or willow family. So that's willows, cottonwoods, and aspens. And they also eat some alders, but they really love the plants in the willow family. And they're eating the cambium layer. So the cambium layer is in between the bark, and it's yeah, it's in between the bark and anyways, it's in between there, and they are eating that cambium layer for nutrients. What's interesting is they will poop out this green matter, and they will actually eat their poop again. Kind of a funny fact. But this is what is driving them to create dams, and I'll talk about that a little bit more soon. But they need access to this food source, and yeah, so here we go. Let's go on to the next slide and talk about why beavers are building the dams. So beavers' main drivers are going to be protection from predators. So like mountain lions and wolves, coyotes, they love beavers. They're super great food source for those carnivores. And so beavers are creating dams to stay underwater. They're semi-aquatic rodents. they have protection underwater. So that is what's driving them. If they're in an environment, there's a stream that doesn't have a lot of water depth, but there's food here, and they see the opportunity. They're in a low gradient meadow area, and there's food, but they just need that depth of water in order to access the food. So they'll create a dam to create that depth, and then they'll create, as you can see in this photo, they'll create a network of side channels and ditches, and they use these networks to access willows and their food source that may be off of the channel out into the meadow system. They're also able to hide from those predators, like I mentioned, that may not want to get their feet wet. So beavers do not live in their dams. They live in lodges, and these lodges may be in a pond. So the photo you see here, this little pile of sticks out in the middle of the water is their lodge. Beavers are accessing their lodge underwater often. So they go underneath, they enter underwater and go up into the lodge. So even mountain lions or other animals that may get to the lodge still are like, can't get in. There's all these sharp sticks and they don't know how to get in there. So it's really, really creative. But beavers are also able to build these lodges on banks. So they're not always out in the middle of a pond. Sometimes they're on the edge of a stream. They create a bank lodge. So that's why they build. They're really motivated by food and by protection. Okay, well, why do they need our help? Why don't we just release, if they're so great at creating this beautiful habitat, this resilient habitat for climate change, why aren't we just releasing beavers and letting them take over? Well, it's quite challenging. There's many factors. For one, beavers are not in the population abundance that they once were. So I'm not going to get too much into this, but you can look at the past, our relationship with beaver in North America. They were looked at as a currency. Beaver pelts were traded, and they were sought after and trapped to near extinction when folks were moving out west and when our country was, just starting. Beaver were sought out for hats and for their pelts, and that was the first step. Now, once folks started to occupy these landscapes that often have beaver, these low gradient meadow environments, it's flat, it's good for people to build, it's great hunting ground, you have the stream nearby, it's really great for humans. So they move in, and, initially they're maybe excited, there's all this life, but then they build a house and they build other infrastructure on the land, they build roads, and they start to run into conflict with beaver. So beavers are plugging up culverts, and they are causing flooding issue for their roads. They're coming up onto their property and chewing down that apple tree that they planted all those years ago. Oh my goodness. And then they go and they kill that beaver because it's a nuisance in their mind. What we are now realizing, all these years of landowners removing beavers, has led to a point where our streams are now looking like this one off to the left. So all across California, all across the West, the country, you see this in these low gradient meadow systems. It's cut down. You no longer have connectivity to the floodplain during regular flow events, or even during a high flow event. Often you're not getting that floodplain connectivity. We have a lot of erosion. And once you start this process of erosion, it's really hard to stop it because we don't have the beaver in there to kind of stop things up, capture sediment, reconnect the floodplain, and create chaos. And the water just keeps flushing down. We have conifer and sagebrush and other types of non-riparian vegetation moving into these systems. And all of a sudden, where's the willows? Where's the cottonwoods and alders? And you see this across the state. It's really hard to see these the opportunity of these meadows has been taken away. And unless now we come in and assist in the recovery of these areas, it's really, really challenging for them to happen on their own. So we'll talk about what we can do to work with the beavers and get this process going in the right direction. So this is a photo of the town of Bieber. It's in northeastern California, about an hour and a half, maybe 2 hours east of Redding. And as you can see, large, oversized channel, no willows, and this town is named Bieber, which is German for beaver. Historically, and if you look at this area, historically, this was a braided network of channels. This is a huge wetland. The soils were spongy. The grasses were green and vibrant. As you can see here, a lot of these grasses up on the floodplain are no longer getting the water, so they're drying out. And there was willows and cottonwoods and alders all over the place. And that's why they called it Beaver or Bieber, because there were so many. Now, there are still beaver in this valley, but nowhere near the populations they once were. And so I'm working with several landowners that have conservation easements that are still using and working with the land. They're still cattle grazing, they're still doing agriculture, but they recognize the benefits of beaver and they are partnering with us to bring them back. We're going to do fencing, planting of willow, and start recovering this area. I can go on, and I will shortly. Okay. All right. So why, I touched on some of these things, but why are we so excited about partnering with beaver? Well, water and carbon storage. These dams are slowing the water and connecting the water to the floodplain, which is like a sponge. So imagine a stream that isn't connected to the floodplain. It's deep, it's narrow, and it's just shooting that water down towards the ocean and taking sediment and other things with it. When you have a series of dams, small dams in a system, it slows that water down. It connects it to the floodplain. So where carbon storage comes into this is wet soils create an anaerobic or lack of oxygen condition that then the plants, as they grow and die and enter the soil and then grow and die, that soil being moist all the time, that anaerobic lack of oxygen condition does not break down organic matter as fast as a soil that may have much more oxygen. So you need oxygen in order for that process to happen. So these areas that are restored and are wetlands are carbon sinks, which is really important for climate change, where degraded meadows may actually be releasing carbon because those organic rich soils that were built up from the past are now breaking down and no longer in that anaerobic condition. These environments are critical for listed species. So there are many endangered species in California. A few I'll mention: the willow flycatcher, the sage grouse. Hold on. There's many, just trust me. There's many species out there that depend on these wet meadows for survival. So the willow flycatcher needs willows, and we have removed a lot of willows on the landscape. So we're really excited about these spaces because they're a refuge for wildlife and for diversity. And I'll explain that a little bit more. Flood mitigation. So again, a stream that is incised, no longer connected to the floodplain, is flushing water through. When you have a series of dams connecting water to the soils, to that sponge, it really takes that pulse, that speed out of the water, wets that soil, and allows for a slow release instead of a release all at once. So there's lots of studies that have shown beaver dams upstream in flood situations really helps communities downstream from those impacts. The fire piece is one of the more exciting pieces. Beavers are firefighters, and my next slide is going to show that. But these wet areas are fire breaks. So when a fire is coming through this system, we have all of a sudden it hits this wet vegetation and it stops in many situations, unless it's a absolutely catastrophic wildfire. But even then, it will slow down and stop and provide a space for animals to be during that fire. It can be really sad to see what happens with these catastrophic fires here in California, but these spaces are refuges for animals during wildfire. Water quality. So as water is coming down the system, one of the biggest issues with water quality is just turbidity of sediment. It may not even be a toxic type of sediment that we're worried about, but just sediment in general can be really difficult for fish, for downstream reservoirs. And so when water hits these dams, it slows down. And as that sediment slows down, it drops. So if these dams are not in place, then sediment is just moving through a system instead of slowing and settling into these areas, which slowly fills up the channel and allows that floodplain connectivity, allows channels to braid. And instead of one channel, I want many channels. That really widens our wetland and makes it more healthy. And as I mentioned, it increases that water surface area during droughts, which is important for all types of animals and plants. Yes, let's proceed. Okay, so a short video that Dr. Emily Fairfax put out, just 40 seconds, but this shows you what I'm talking about. I'll let it play and take one moment. So those are the little channels that they build to reach their willows out in the floodplain. I highly encourage everyone to go to Dr. Emily Fairfax to their website. They are a beaver scientist. They made this video. What they're putting out there about beavers and wildfire is incredible. There's some amazing photos that show these burnt areas and then these areas with beaver dam complexes that are just fully alive and thriving after a wildfire. So check that out. It should, Smokey Bear, it's not Smokey the Bear, it's Smokey Bear. I don't really know what he does for firefighting, but they really should change it to the beaver because they do much more for firefighting. All right, here we go. So just another visualization of this. So when we have incision and we don't have floodplain connectivity, the grasses dry out, we have conifer and other types of non-riparian encroachment, and that is more susceptible to burn. I mean, it's pretty straightforward and makes sense if you think about it. And then this graph is showing what I mentioned earlier, the reduction of peak flow. So in beaver dammed systems, we are seeing water later in the year because of that sponge. It's quite profound. The water is not just flushing out, as you can see here. All of a sudden, spring runoff hits and boom, all the water is out of the system. And then we enter the dry time of year where in California, we get no rain and everything is struggling to survive at times, and grasses are drying out. And in a beaver dam system, we're getting water downstream later in the year. This is really, really important for communities, people, and wildlife. And now I'm going to tie it to renewable energy because that is our theme of this year. There's several ways we can think about how beavers and renewable energy interact. So first, there are hydroelectric power accounts for 28% of US renewable energy generation. And so hydropower is an important piece, but in California, in many areas, that infrastructure is aging And the cost to maintain these systems is increasing. The sediment buildup behind these structures in these reservoirs is becoming an issue. And one of the bigger issues is that when we put these in, we disconnected these stream networks for fish and for the people that use these rivers. So salmon are no longer able to move through these systems. The people that depend on salmon are native people of California that really rely on fishing salmon and on these healthy natural systems don't have that in a lot of these areas. So we're starting to recognize that although hydro is a renewable energy, the movement of water is totally a great renewable energy piece. There are some harms, and they're coming down. And solar and wind and other renewable energy sources are coming to the forefront. And so I feel like we're starting to see that the negative parts of hydro don't outweigh the benefits, and we can start to rely on some of these other energy sources. Now, this is though those are some big blanketed opinions, but I think it really, especially in areas where we have degrading reservoirs, when we have maintenance concerns, it certainly is true, and we got to get these systems back into their natural state. These dams are anyways, I can rambling here. More water storage. Okay, so these dams and reservoirs are important to the state of California's water infrastructure and water storage, not just energy, but also water storage. So when we start to take these dams down, it's going to be even more important that we have healthy meadows and streams that feed these larger order streams up above these dams. So let me try to say that in another way. Instead of 1, 2 large dams, we need hundreds, we need thousands of small dams that will still act as water storage in our upper watersheds. That the graph I showed you a moment ago, that slow release later in the summer, we're able to achieve water storage goals by building hundreds or thousands of small dams in our headwaters. And that will also be important for holding snow and preserving biodiversity and so many other amazing benefits. So watershed restoration, especially after we start removing these dams, is going to be really crucial. And the beaver dams are going to also help protect rivers, fish, and reservoirs from sediment. So let's say we don't remove a dam and we're working in a system that has a dam and a reservoir downstream. By having healthy populations of beavers, or by having good watershed restoration practices happening in these tributaries, we're keeping sediment from these reservoirs. It is extremely costly to remove sediment from reservoirs. And it's really important because as sediment fills a reservoir, you lose capacity in that reservoir for water storage. So it's a cost saving. The cost savings is huge. And there's a partner I'm working with currently that is actually trying to quantify this cost savings. Also in relation to hydraulic mining and the importance of keeping those sediments in those areas out of streams. But if you are interested in this at all, I would recommend checking out the Sierra Fund's website, and I have a bunch of resources I'm happy to share with folks. Fish, really quickly, salmon need, in order to lay their redds, they need cobbles, and these fine sediments can clog up those cobbles and create an environment that is not great for salmon to lay their eggs. So it's important to trap the sediment before it enters these larger order streams, and that's where beavers come in. This is just showing the dam removal project that is happening along the Klamath River. It is the largest dam removal project in US history. They are going to be removing 4 dams from the Klamath River. They have removed the first dam, and the rest of them are scheduled to be removed this year. It's a really exciting time for the people of this area. I live down here, kind of near Eureka in the town of McKinleyville, and it's definitely the talk of the town. People are really excited to see the salmon run return to the Klamath. It's going to be extremely important for those populations. Um, yeah. And let's see. Pacific Corp even mentioned the potential for savings because of the maintenance issues on these dams, and for removing sediments. They actually expect, even though you're taking away power that is being generated from these areas, they actually do expect to see a rate decrease. And there's other ways that we can go after power, like solar and wind, like I mentioned. Okay, so this is where I come in and my team, in the site preparation component. So what can we do for these areas that aren't ready to just release the beaver and let them do their thing? Well, improve the habitat with PBR, process-based restoration. So low tech, specifically process-based restoration, is using the energy and power of water, what we have, stream power coming through a system, and using that to our advantage. So we are building beaver dam analogs, woody debris structures that use that stream power to capture and aggrade or build up sediment behind these dams. We can also use stream power to widen channels that are really deep and incised, but we can have some widening that happens with some of these channels. So actually encouraging some erosion to then have a series of BDAs below, or beaver dam analogs below, to capture that sediment, helps reconnect the floodplain. I'll get into this a little bit more. We may need to plant willows, cottonwoods, or aspen, in order to provide that food source and that building material for the beavers. We may need to protect or remove roads and culverts. So if there is a road and a culvert, and beavers are probably going to plug that culvert, that's what they do. Well, there's different things we can do to protect that culvert, and I'll show you guys in a little bit. Or can we remove that road? That road is a problem. That road, it may be cutting across the meadow, maybe not allowing the meadow to have that braided channel network, maybe restricting wood or sediment from moving through a particular part of the meadow. So maybe the solution is to remove the road and move it to the hillside, and then have that full connection, of the meadow again. And then reduce herbivory competition. So maybe cattle are causing too many impacts on this meadow. We don't always have to say, well, no cattle at all. We can work with cattle, but we're going to need to be active managers of that. So putting some fencing in to rest an area. If we do a planting, we will rest it for a while and allow those willows to get a little bit above head height so the cows won't eat them. The cows seem to like willow a lot. So what will happen if cattle do get to the willows before they get above head height, and they just strip all the leaves off of them every year, they really struggle to establish. And I've had complete losses from cattle overgrazing my willow plantings. So fencing may be important. Another interesting one, is wolves too. And we have wolves that have returned to California. Wolves keep deer, keep cows, keep those types of animals from loafing around in the same spot. They keep them on their toes. You can't be complacent and hanging out in the same spot if you've got a pack of wolves on behind you. So wolves are an important component too at keeping those types of animals moving and not in the same spot, crossing the same part of the channel and creating erosion and issues in a system. Okay. All right. So here's an illustration and then a couple photos of a beaver dam analog that I built out in Modoc County on Fitzhugh Creek. This is on BLM property. Pretty good size BDA. I like to build about 1 to 2 foot structures, and I would rather build numerous structures than some really large ones. Sure, Beaver do build some really big dams, amazing, but they're also there all the time working on those dams, fixing holes, keeping them going, and I can't be there all the time. That's also partly why I have these posts that I drive into the ground. So these are non-treated dug fir that I drive into the ground, and that helps allow this structure to last a little bit longer. My goal is to have it stick, have some sediment as it comes in and hits this dam, it slows down and drops. And if we can fill and start to fill some of the pond with sediment, that's going to bring that channel up to the floodplain. And maybe it creates a couple new channels from one channel to three. And that's part of the goal. The posts just help us make that dam not blow out in the first season. We are experiencing a lot of these flood events, these kind of more extreme events that are kind of hard on beaver dams. So if I could get this to establish with some sediment backing up behind it first, then they're less likely to blow out. Even if they blow out, not the end of the world. Because we're still in the process of maybe a dam blowing out. We got some sediment recruitment. We have some willow growing because we integrate willow into our structures. And maybe we widen the channel, and now the channel is no longer one, but maybe it's three. So there's various levels of failure in one of these blowing out. It's not always a complete failure. This is that same dam, and then I have several other dams that I built in here. So right here by the tree, kind of in the midsection where my pointer is that large dam. That dam was crucial, and I built it first because I brought the water up and reconnected this inset channel here. This high flow channel, my apologies. So this channel off to the left was only receiving water during a super high flood event. And then in the summer, this was just bone dry, no water in it at all. And this meadow is no longer this wet green sponge. It's not meeting its fullest potential. So the structure we built here shot water off to the left. I built a series of dams in that channel to bring that up and continue to connect the floodplain. What's really exciting is this project did really well. So this is another shot. Look at the green vegetation that we've created behind the structure. It's just incredible. And the willow that we integrated into the dam is alive. It's 12 feet high. It's become a living wall. So it's like, it's now part of the landscape. I don't know, it's not really going to fail. It's now part of the landscape. It's a live structure. Sediment has built up behind it. Here's another shot of all the willows that are growing out of the structure. And yeah, so here's a shot of kind of my team getting started here. So we have a 4-stroke post pounder that's about 45 pounds. That drives the posts into the ground. For a beaver dam analog, they will typically have a nice kind of post line like this. And then we are using conifer and willow and sod and gravel. We're layering it in. It's kind of like mud lasagna. You start small and you want to work deliberately, having branches facing upstream, kind of the bushy end of the branch facing upstream. And we start to create this lasagna of branches and then sod or gravel, and then branches that are hugging that, and then more sod or gravel. It's a slow process that ensures that these structures don't undercut. I'm okay with end cutting or widening of a channel, but I don't want it necessarily to cut under the structure, undermine it, blow it out. So we're slowly layering that in. And then the posts add areas for us to then go and do some weaving. So we can take some willows or some smaller diameter conifer and weave them in and out of these posts, step down on those posts, and it locks that material into place. Then maybe we do some stuffers. Anyways, it's kind of like an art. It's also a dream because we're out there, we're like kids playing in the creek for work. It's incredible. I can't believe that I've fallen into this. It's hard work, but I personally love hard work. If I could be outside like doing physical work all day long, I'm not thinking about anything at home or in the world. I am just building beaver dams, and that is incredibly therapeutic. And my employees would probably, talk about their own experiences with it. But this type of work is so gratifying that we can actually see the impacts of the work immediately. You're seeing the water connect other channels. That is what we need right now in a world that has a lot going on that maybe seems negative. This is just so gratifying, and I highly recommend you guys come out and build with us. So here's another shot where we're integrating some conifer that was encroaching on the meadow into the structure. There's also post-assisted log structures. These are a little bit messier. They may not have a kind of a linear post line. I may not add as much sediment or sod and sediment behind them to get them started. They may not quite pond up as much, but they can work. So depending on the system, this is faster. And if we have a system that has a lot of sediment moving through it, we can fully let process do the work for us. We put a whole bunch of wood in the creek. I stuff the bottom of it as much as I can. Maybe I'll throw a slab of some sod and a little bit of gravel on there to get that process starting. And then you just walk away. So in a system where this works, it can be really, really fast, cost effective, and create a complex habitat that is no longer just cutting, but widening. So those are fun. Sometimes you're just falling trees from the edge of the creek right into the channel, stuffing some other trees in, throwing a couple posts in there and moving. Postless structures can also, sometimes you don't need to use posts. So this just shows sometimes you have huge wood, big, large pieces that you can just fall into the channel or fall a tree from the edge of a meadow into a channel. And I know the stream power is not enough to move that wood. And even if it does move the wood, I don't care. It's going to go downstream. It's going to rack up in another structure that I have downstream that may have posts. And so that's fine. The photo here on the top right is a small little beaver dam analog. Now, for a small structure like this, I'm not expecting beaver to come back here, but the structure that is inspired by what beavers do is still beneficial for this headwaters meadow that has channels. These small channels are incised, and I can create a little structure using conifer trees that I make posts out of, put some willows in there as posts, do a little bit of a weave, and keep that water connected and sponging out into the meadow. So these little ones are really fun to work on. And then I mentioned willow planting. So in systems that don't have willow, we need those willow, regardless of whether our immediate goal is to bring a beaver back in. Having willow in an environment like this is super important for birds. Birds are going to use willows for nesting. Just so many important things with willow. So anyways, here's the willow planter I designed. It's a T-post or a rock bar that I welded a T handle on top, and then I welded a foot pedestal here. It looks like a pogo stick. And you just grab that thing, shove it in the ground, step on it, and it gives you a nice a nice hole to shove the willow in. That's about 1.5 feet in depth. So here's another shot of us using it. It's pretty fun. It is heavy. It is a lot of work pulling this thing out of the mud sometimes, but it works really well. And it's hard to see her, but here's my dog in the sled with a bunch of willows. And so we use these sleds instead of wheelbarrows in an environment like this that is moist. those wheels, you get it. It wouldn't really work out. These sleds work out for us. Low impact, don't create any ruts, and they also float. So we use them to harvest sod or gravel from upstream when we're building a structure, and we can float that material down to the structure and dump it in. We're not always trying to use our muscles to do the work. We got to let the river do it. Here's a shot of me and my dog again, planting willows out in an area that really needs willows. And one of my employees harvested a bunch of willows, and then here's a bunch of nice conifer branches. So it appears that they are preparing to be working on a beaver dam analog below and just prepping materials. So like I showed you in the other photos, we use a lot of willow in the structures so that that structure sprouts, becomes alive, and is strengthened by that. Okay, and then another shot of the willow and how incredible it is. I have a lot to say about so many things, but I'll quickly mention this project is something to highlight. This system was burnt. So another part of the fire story is when you have a landscape that burns, those soils are highly erosive. And so there is an opportunity in, despite this fire happening and all of that darkness and negativity that one may associate with fire. Well, when it comes to meadow restoration, there is an opportunity to capture sediment and reconnect our floodplains. We know a lot of sediment is going to move through a system. So if we time it right and we put structure in before a big runoff event moves across that burnt landscape and sends a ton of sediment downstream, destroying roads, flooding homes, and all these things, if we have structure in place, whether I built the structure or Beavers built the structures, it will protect and help connect floodplains. So protect downstream communities from all that sediment. And then we can capture all this sediment, quickly bringing that channel back up to the floodplain, where if we didn't have the fire, it may have taken a long time for natural sediment recruitment to collect behind these structures. So kind of a cool opportunity. This project worked. I built these structures after a fire, and in one atmospheric river event, we captured sediment to the top, filled every single beaver dam analog out there from the top all the way back with sediment. We then came back in, built them higher, added more willows, did a little bit of maintenance, a little bit of phased implementation, and those structures are doing incredibly, and they continue to capture sediment. I'm going to be going in this year to the same site and doing another phase. So one last point on that. With this type of restoration, it's not a one and done. You don't go in, we're not building concrete dams, we're not building highly engineered structures that require an engineered seal of approval, and it's costing a ton of money and you expect that structure to be there. It's not quite like that. This is a living, dynamic type of restoration practice that requires years of maintenance sometimes. Sometimes it could be highly effective on its own, depending on the conditions, but in other times it may take a community to be involved, a school that is nearby, or some volunteers, because I can't be at all of my restoration sites that may need a little bit of touch up. So a big thing I'm trying to do is building community engagement with these structures so that we have human beavers out there taking maybe even 10 minutes per structure to patch a couple holes and add a couple more willows. And it's incredible what that can do for these structures. So a big community engagement piece. It's really fun. Okay, now let's talk about beaver again. I just going to take a quick moment. I think I'm doing good on time. I have a 3-minute video. I'm seeing some nods. Yeah, I'm going to play this video. This is a 3-minute video. For the first time in 75 years, the California Department of Fish and Wildlife is thinking about beavers again. They just hired 5 permanent positions to help promote beaver reintroduction, watershed restoration. And the first reintroduction happened just downstream of a project of mine. So we built 100+ structures upstream of where the beavers were released. And then another company and individual, Kevin Swift with Swift Water Design, built hundreds of dams down in the valley as well. So it's another company that does beaver dam analogs. So CDFW saw this site, was like, we got structure upstream, we got it downstream, they got food. We have no cattle grazing here. We have a landowner that's willing. This is perfect for our first pilot release. And it was super successful. So with that, I will take a break from speaking.
Today is so significant because this is about restoration. This is about bringing back an animal, and it's about what that animal can do.
Today just feels really good. We're bringing something back home. We're returning an animal home.
At the end of the day, our core mission is to help people and nature thrive together. And there is a lot to be discouraged and alarmed about in our world, whether it's climate change or the loss of plants and animals off our planet. But when we take action, we maintain our hope to restore, to regenerate our natural world.
The part of our history where we viewed a lot of animals as nuisance, varmint, and we shot them off the landscape, from bison all the way down to beaver and many things in between. And when you bring them home, you'll restore your ecology. You'll get your healthy functioning again in your meadows, in your alpine streams, in your coastal estuaries.
We're so excited to learn from our tribal partners and scientists that this meadow will be so much healthier and more functional with beaver in it. It will retain that snowpack that melts in the spring for a longer period of time, creating healthier, more abundant rivers throughout the year. It's going to create more of an ecosystem, more habitat for plants and animals that call this place home.
They're our little cousins, and we're gonna pray for them to be safe, to have a good life here in this beautiful environment. And so we're so happy to be able to release them here, and we pray that they will find a good home, make a good home forever here.
I got a little choked up and teary-eyed. I saw the beavers come into the water and some swim off. But 20 minutes later, they're out in that pond making a home. And this could be forever. And that's the right thing to do.
All right, and that gave me a moment to realize I am a little bit over on my time, so I'm going to kind of move through some of my next slides here. But what incredible opportunity to be a part of that project, and so stay tuned if you want to come out and check that out. We do trainings out there every year. Okay, so here we go. Child's Meadow. How can I go to a full screen again? One moment. Okay, forget about it. Here is a beaver dam at the bottom of a project that we did last year. Amazing project. Now, the beavers in this area were having a hard time just maintaining a foothold in this area. There's a lot of energy in the system, and their dams are blowing out. And that could be for many reasons, but floodplain not having floodplain connectivity upstream, a lot of stream power in this. And so this dam continually gets blown out. So here it is blown out. That was a really important dam holding back a lot of water. So one thing we did is rebuild the natural beaver dam. So I got my sleds, got my posts. First thing, we start driving in the post to create structure. Then I start integrating conifer, bushy end facing up to capture the sediment. And I'm layering it in. I'm creating a cross hatch pattern. I'm weaving material in. I'm trying to lock it in as much as I can. And then adding some gravel and some sediment slowly in layers behind. And then boom, it's rebuilt. So we got this first phase rebuilt, and then we built 92 structures upstream of this. This is the bottom of the system. At the end of the season, after building 92 structures upstream, we had a little bit of time, and this dam was really important to me and to the beaver. So we put some large, heavy logs on the backside of the dam to weigh it down, and I added a bunch more posts. I really wanted this thing to stick. This is creating incredible habitat for the beaver, and so I did a little bit more work on this. What was amazing and the most exciting piece is at the end of the season, the beaver had already adopted this structure. Small bits of chewed branches were all over the seam of this structure, and they already were like, wow, this is awesome, and moving in and starting to do some work on the structure themselves. This is down at the bottom, that beaver dam that I just showed you. And then this is just showing the rough spacing. All of these are beaver dams that we built, beaver dam analogs that we built to help support beaver in this system. So the more, the better. And all right, living with beavers. So I mentioned this a little bit before, but yeah, they cut down the tree that you don't want them to cut down. So there's different paints out there that have sand in it. You can cage trees. And then up here in the top right is, I mentioned the issues with culverts and beavers building dams in the culverts, and then the road washing out. So this type of design, this shape has just been vetted. It works. The beavers start to build on that fence, and they just start to lose interest, and it doesn't really work for them. And then they move on to other places. And then the one here in the middle is showing that there is a way to maintain the level of a pond. So if a pond is getting too big or out of hand and causing issues for homes or other types of infrastructure, we can control that level, still allow the pond, but we don't want it to get quite as big. So you can control that with a flow device. All right, and I could go on and on. I am going to conclude. Please go to calpbr.org. It is the collaborative I'm involved with. Everyone involved in beaver restoration across California is in that group. Volunteer. I have a team. We are going to be working once, probably May to this, when the snow starts flying in November, all across California. Go to my website. I have a map. I love having volunteers. I partner with NRCS's Earth Team volunteer program to have volunteers out on our projects. And there's a job and a role for everyone. So you don't have to, anyone can put a stick in the creek, and it's much more fun than you think. And then we also have training. So if you're like, wow, this is incredible, I can't believe that this could be a career. Well, whether after high school or after college, if this interests you, I highly recommend coming to one of the trainings where you can learn how to be a PBR practitioner. And with that, thank you so much for coming here to learn about beavers. I'm extremely passionate about it. They are going to be one of the keys to maintaining hope and fighting a changing climate that we have. And it's just really exciting to be a part of this. So thank you so much for being here and hearing me today. And please share and spread the word about the importance of beavers. Awesome. Thank you. And maybe for the Q&A, which we'll do here in a moment, Frank, I think you're muted.
Yes, I am muted. My bad. Yeah. Thank you so much for this absolutely phenomenal presentation, Garrett.
Thank you very
Um,
much.
yes, so we do have two questions from Jovita to kick things off for our short first Q&A session. Her first two questions are beavers attracted to BDA projects and remain in the area or build their own dams?
Yes, so they are. The one project I highlighted here at the end is definitely the one where beaver are already right there in the system and they're already adapting our BDAs. I mean, just after a couple months. A lot of the other projects that I built didn't quite have a beaver that close to adopt it so quickly. But yes, Kevin Swift, Swiftwater Design has numerous examples of beaver moving into these environments that we help create. So they absolutely see these and know what to do. Who knows if they think we're doing a good job, but they come in and they do a better job. We build them faster, they build them better because they're there to do the maintenance all the time. So yeah, they do like it. And remind me, what was that second question, Frank?
Oh, yeah, the second question was, how do you monitor the success of BDA projects?
So you can do biological monitoring. So we have a lot of partners that are monitoring amphibians and birds. So they're doing surveys, looking at wildlife. And then you can also do water 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 wells. So you put these wells out into the meadow, and we can show groundwater, how groundwater is influenced and is raised up, and also the temperature of water. So there's various different monitoring. There's drones you can do monitoring with. There's basic photo monitoring. I would say all of my projects have some component of monitoring, some more when we have great nonprofits that come in and bring funding to do monitoring, and some less that maybe could use more. But it's always involved.
Awesome, thank you so much. Does anyone else have any questions to enter in chat, or you could come off mute and present your question? We'll give it about 1 more minute before we switch to our second presenter. If you have any questions, you be more free to put them in chat, and we can also address them during our second Q&A session coming up in probably 20 some minutes.
Yeah, and if you don't want to present your question here, you can email me or call me or whatever. I'd love to engage with folks that are interested in this and help connect you with other people that may be closer to where you live or anything like that. So just shoot me an email if you have any questions.
This is Jovita once again, and I'm sorry to be hogging all the questions, but I have one about partnering with local ranchers, because you were talking about cattle.
Mhm.
I know that some ranchers do time management grazing, so they do a quick grazing for young willows that are developing along stream banks. Do you have you built relationships with these local ranchers or the local cattlemen associations? Or do you meet resistance from them?
You know, I not too much resistance. I think I could probably find resistance if I wanted to find it. But I would say partnering with NRCS. NRCS is a big partner of mine for conservation easement properties. So I have worked with 4 or 5, maybe 6 different landowners that do cattle grazing, and it's through the NRCS conservation easement program, and or EQIP. There's also EQIP funding through NRCS. Yeah, it is growing that it's important to have these healthy systems. It increases forage because we're bringing the water up, we're growing grass. If we can work with the beavers, you're actually improving so many things on the land. And a lot of ranchers are recognizing that. They don't want to hand their land off to their future generations that is just degraded, has no wildlife habitat, and the water is just flushing out off of their property. They're realizing, oh wait, I may have to do a little more work with cattle management, but the result is going to be birds and wildlife and soil health and all kinds of things. So the best person to tell another rancher about this is a rancher. And so there are some rancher advocates out there that I like um, to help share that message. And yeah, it's definitely growing.
Very cool. Thank you. And I know there's one more question, but I just want to thank you. And I really am jealous you have such a dreamy job.
Thank you so much.
Yeah, our next question is from Sean Ashley. Her question is, what's a conservation easement?
Mhm. Conservation easement is an agreement with the government to restrict land use practices um, for the benefit of everyone, for the benefit of wildlife, for the benefit of water. So a landowner that enters into a conservation agreement is going to have certain restrictions. They may not be able to graze it as they would before. They may need to integrate some fencing, and they may have to change the way they do things. But in return, the government will help them with a subsidy, with funding, so that that can offset maybe a little bit of the financial blow they may take from transitioning. And yeah, it's a really important incentive for private landowners to do restoration. And NRCS and the government will also help pay for restoration. So not only do you get the check at the end of the year or whatever term is identified, you will also get restoration help paid for. Often 75% of the restoration paid for, and the landowner may only need to pay 25%. So it's an incentive for the government to help heal private land.
Awesome. Awesome. Thank you so much for answering those questions. Um, if we want to transition right now to Marcos's presentation, if you want, you can stop
Oh yeah.
stop sharing your screen, and then Marcos can hop on.
Sorry for going so much over, Marcos. Hopefully
No,
folks
that's
can stay. And if they can't, they can watch the webinar later or something.
true. Hey, Garrett, thank you so much. I really appreciate your presentation and what you showed. You talked quite a bit about hydrology in there in terms of how different dams can help out with sedimentation. It was perfect. It was brilliant. So what I'm hoping to do is piggyback a little bit off of, sorry, I'm looking for a search, off of Garrett's um, workshop and talk about how we can predict or how we can analyze uh, locations that are where we're interested in putting these beaver dam analogs and figure out, okay, if we do put a beaver dam analog there, what kind of impact is that going to have on the stream? And that's the science of hydrology and also a little bit of hydraulics, where we can actually predict where that water is going to go if we put a dam in a given location. And the way that we first start looking at that science is we have to talk about things called watersheds. It's it's the way, it's not perfect, but it's the way for us to be able to get an understanding of the area around a point of interest, like a beaver dam analog, that may contribute flow. So as it rains in the mountains or as it rains in, all that rain collects as a certain location, it's going to drain to that beaver dam analog. So how much rain, what is this volume of water that's gonna get there? And so the science of hydrology is the way to answer that question. But before there, we have to draw these watersheds. And so we're going to do a very practical exercise in how to draw these watersheds. The first step is to find something called a topographic map. This is not a topographic map that I'm showing you. I'll show you here in a second. And what topographic or topo means, it refers to elevation. So a topographic map is a two-dimensional way to represent three-dimension, right? So on a flat piece of paper or a screen, we can see three dimensions using something called contour lines. And I'm going to switch over to show you that now. So here's a fairly typical topographic map. And you see all these squiggly lines all over the place. Some are blue, some are black, some are brown. So a very simple look at a topographic map. The black lines or dark lines are always going to be roads. They're going to indicate where some type of a human interaction. So you see these squares where they're towns. So those are human structures. The brown, that's going to be the ground. So brown is ground, very easy to remember. And then blue are always going to represent water of some type. Now, when we're concerned about when we're looking at trying to come up with a watershed, remember that's that area that contributes, that's going to contribute water to that beaver dam analog or that point of interest that we have. These brown lines are lines of elevation. So if I was to walk along this line of elevation, I would never change elevation. I'd be walking flat, even though it's squiggly here on the 2D. Now, once I go perpendicular to that line of elevation, I'm either increasing or decreasing. So here we have several contour lines, and the way that we represent each contour line is a single elevation. And when we go to the next contour line, that goes up a certain amount of feet. And so in this case, this is going to, we'll figure that out here. So we're going to look at this contour map and we're going to figure out, okay, well, what is each of these lines of contours, each of these contour lines, what do they represent? So if we look here, we've got some numbers every now and then. So here we have 6,000, 7,000, 8,000. And those lines along those are a little bit darker. So this line, as if I was to follow that, I would be walking 6,000 feet of elevation. And as we look to the next line, uphill, it's 7,000. We're gonna just count, and that's gonna give us our units for each contour line. So if this is 6,000, that's 7,000. We've got 1, 2, 3, we've got 4 lines in between. That means we've got 5 spaces. So it's 1,000. Well, what's 1,000 divided by 4? 250. So each of these lines should be about 250 feet of increase in elevation. So this would be 6,250, 6,500, 6,000. Oh, sorry. I gotta go more than that. 1, 2, 3, 4. So we gotta do 5. So 1,000 divided by 5. Do some fun math here. So is that 200? So 2, 4, 6, 8, 10. Yeah. So each time we go up a contour line, we're going up 200 feet. So quite a bit of elevation. Now, when we're trying to get a watershed delineated, that's the appropriate term for drawing a watershed or creating a watershed. We say delineated. And all that means is to draw a line. This big dot here is our point of interest. So this would be imagining where a potential beaver dam analog may go. So what we have to do is figure out how much water could potentially go to this location. And the first step is drawing the area that contributes water to that location. And the science behind this, or the way to do it, is very simple. When we're looking at elevation, we're going up elevation to these different contour lines. We're going to look for peaks and try to follow the peaks. And the idea here is along this line here, this circle, this is going to be around the highest point in this hill here. So if it rains on this side of the hill, the water is going to go down to the east. If it rains on the west side, it's going to go down to the west. So water is always going to travel downhill. So what we're looking for is we're looking to draw that line or that divide between where the water is going to go one direction and the other. And so if you have your papers out, we'll do this together. I'm gonna do this digitally. You always want to start at your point of interest, or sometimes called the outlet. And that's going to be the lowest point of elevation in the whole watershed. So from that point, we need to go uphill. And from here, I see this circle represents a nearby peak. So if I go up and click right at that circle, that would be my first, another good point of reference for our next highest point. To get to the next peak would be around here. But to get there, what we're going to be looking for is what's called a spur. And what a spur represents is the ridge or top of the hill that we're climbing. And spurs are easily seen by, here, let's do this real quick. A good example of a spur is right here. So we've got this, it kind of almost looks like an isthmus, right? As we go up this, each side, we're going right up the ridge here. Another example of a spur would be this right here. So these sort of U shapes, parallel contour lines. This right here would be a spur. Try to see if we've got some really good ones around here. Here's kind of a bigger spur. But you're always going to try to climb up the convex part of the watershed. All right, so let's go back to drawing. And it's okay if you don't get this perfect. Really just looking up. So we're going to go up this spur to that peak. We're going to go up this spur to the next peak. And then if I go this way, I would be outside the watershed. All this water is going down this direction. So I'm trying to find out where I need to go for the next one. And it looks like this circle here is going to be our next peak. So if water rains on this side, it's going to go that way. If it rains on this side, it's going to go downhill that way. So we're going to go through this fairly quickly. You can see I'm using the middle of the circles to find my way. Now from here, where did I go? So I've got these higher elevation. This is a lower elevation down here. But this roadway here kind of gives us a hint. So the next point of highest elevation is going to be somewhere in between here. And then we keep going. Here's another circle. And this is going to start getting kind of tough. So this right here, this is what's called a draw. So if water were to hit here, it goes down, and then so it looks like we're still good because we're going up elevation a little bit more. And this is where it gets a little tough. We need a topo map that had a little bit more resolution to it in terms of not just 200 feet between contour lines. But what you see here, we've got these little bumps here. What we're going to do is we're going to stay on the side. So if it rains here, water is going to come down and go this way. This right here is a little creek here. So we're going to come down this side. Once we get to here, this spur, we're going to cross over. So if it were to rain on this side, we'll go this way. If it rains on this side, it'll go down here to this creek here. We're going to go a little bit fast here up this. So again, we're finding the different peaks. Now what we're doing here is we have to make our way back down to that watershed or to that outlet, that Beaver Dam outlet. So if water hits here, it's going to go down. It's going to go past that outlet. So sometimes what helps is to start back at this outlet and see, kind of trace back where this would go. So here's that first spur, right? That U shape. So it would go up here, come up this way. So it looks like where we need to go is about here. And then we need to start going down. This would contribute that way. And we'll close it off there. So that's an example of trying to hand draw these watersheds. See, it took a little bit of time, a lot of questions as you're going back and forth. Could it be this way? Could it be that way? In the modern era, the USGS, which is the U.S. Geological Survey, it's a federal agency that is in charge of what's called the National Elevation Data Set. So what they do is they have elevation information for the entire United States. And they took all that information and they digitized it. And now because it's digitized, we can actually automatically draw these watersheds and very quickly get a sense of what that watershed is and how much area contributes to that point. So we're going to do that same thing, but we're going to do it automatically. So this is that same area. Change the map a little bit. That same area, this is that point of interest or outlet where the potential Beaver Dam analog may go. I'm going to clear this so you can see how fast this works. Now, in order to do this, all you need is a latitude and longitude. Latitude and longitude, think of it like X and Y on a coordinate system. And once we have a latitude and longitude, I got that here. That's usually any GPS can pick up your latitude, longitude. So what I did, I'm on the site called streamstats.usgs.gov, free website. Anybody can access it. You don't have to use your name or log in. I haven't logged in. Streamstats, any browser, you'll be able to find this. And I just plugged in our coordinates. I'm gonna hit California, and then you see we've got this network of streams. And this is all based off of the elevation data set that's behind this. I'm gonna click delineate. I'm gonna look for a good spot to delineate. So we're gonna put this just a little bit higher. And you'll see much faster than what we did by hand, we'll be able to have a watershed for this area. So essentially what the hydrologists have done at USGS is that they have all these little pixels. You can see it's very pixelated, and there's a elevation associated with each of those pixels. And they use that elevation to help automatically draw that watershed. So there we have, much faster than what we did by hand, our watershed. Now, quickly, once we have that watershed, the idea here is any rain, any snow that melts in this area is going to end up at this point. Now the question is, well, how much is that? And that's where the science of hydrology comes in. There's several different types and methods of hydrology. USGS here uses something called a regression equation. And we're going to go through that so you can see the actual volume of water that we can get. So I'm just going to continue through this automated model. Now this maximum probable flood statistics, think of that as the most potential rain that could ever happen in that area. So this is a lot of water. And what this is showing, this value may not mean much to you right now, but this is 54,600 cubic feet per second. So this is a flow of water. So it's more than just a volume, it's a volume of water per time. So at that point, and the most amount of water that could flow there, we would have that much. So probably more than a beaver dam can handle. But that's not what we're designing the beaver dams to do. We're not designing to hold back that water, at least not that much. So we're going to go back and check out real quick. Another report. Called the peak flow statistics. Now, where does this help? A lot of this was designed when we're talking about building dams. Once you have this flow number, you can actually translate that amount of flow into an amount of energy that can be produced. So what this is showing us gives us a few different pieces of information. So there's quite a bit of, it gives us the precipitation, the average elevation in this area, and then how big that is in square miles. So fairly large watershed. Now what we're seeing down here, where it talks about 50%, 20%, 4%, statistically, what this represents is the amount of water that could be expected in a given year. So this value right here, this is 3,650 cubic feet per second of flow. That amount of water has a 1% chance of happening. So not a whole likely, not a very big chance of happening this year. So when hydrologists are modeling, they have to try to make a decision, which one of these do we use for modeling the impact on the structure? This number right here, this has a 50% chance of happening. So more than likely, any beaver dam analog that's built in that area is gonna see this much water, about 400 cubic feet per second flowing through. So now with that, we can take this science of hydrology and be able to use another science called hydraulics. We won't talk about that, but this would be the start. Once you find this flow, you can start to understand what kind of impact the a beaver dam analog may have and model it. And I'll stop there. So you all know how to draw a watershed at this point.
Thank you so much, Marcos. Your hand-drawn watershed was actually very accurate compared to the one on USGS, I think.
Yeah, and if I
It's
could just add
close.
one quick thing, great presentation, thank you. So where you delineated the watershed is actually just upstream of the natural beaver dam that is on my cover, my
Oh,
first.
really?
Yep.
That's
Oh,
awesome.
And is a decent ways downstream from the bottom of the project area that we worked on. So A little bit more flow as you get farther down that system. And like he was mentioning, we use this to think about like, so for me, I'm thinking about how large of posts do I want to use? How much weight, how robust do I need to make my structures? And for a larger watershed like this, more posts or larger diameter posts may be warranted if we want it to survive the first season. So this is really helpful, and I use this stream stats tool every time before I do projects to get information like this. So yeah, thank you.
Nice.
Awesome. Yeah, we came full circle with this presentation. Well done. Does anyone have any questions? We are now entering our second Q&A session.
I have a question. I want to thank Marcos. This has just been so informative. I've read topographic maps on many, many backpacking trips, and this really, I learned even more from your instruction, Marcos. But my question is actually to Garrett. So, Marcos mentioned modeling, hydrology and hydraulics. Is that a tool, since this is a lesson on this kind of tool for delineating watersheds? Is this something that you use in determining where to place, your BDAs, like you did, like the 90 something you did upstream?
Mhm. Yes, this is part of that process. But I feel like as for identifying locations, different tools, I'll use LiDAR. I'll actually go out and do topographical analysis with lasers on site, doing cross sections across the meadow, a longitudinal profile walking up the stream. So I'll collect data in the field, and if I have LiDAR, I'll look at that. I'll look at different maps. Historic maps can be helpful. Yes, all of these things are really helpful, but there's a lot to be said about diving headfirst and getting muddy and figuring it out while you're out there. So I do a lot of modeling, but this is a little more art form than highly engineered type of restoration structures. I'm letting the stream tell me where to put it next. So I often start at the bottom and I work my way up, and I'll build a structure that's 1 to 2 feet in height, and I'll see where that water backs up to. And it often backs up to another riffle or an area where water is more shallow. So not a pool, but an area where it's riffling over the rocks. And maybe I'll leave the riffle because I don't want to delete all the riffles in the system, and I'll go to the next riffle, and that's where I build. I build in riffles, not ponds. And a lot of it is honestly done on the fly in the field. So I'll just field adjust. And but these things are helpful too. Absolutely.
Fair
So-
enough. Thank you.
So this is one question that popped up late, and it's also for Garrett, is when you're working in these waterways and installing beaver dam analogs, do you have to get permits to install them? Or do you basically get permission from agencies right away for you to be able to install these BDAs?
Permits are required. So there's several different permits. CDFW has a permit. Then you have more water focused from water boards, the 401 permits. There are various permits out there. Army Corps has a permit. We are streamlining permitting processes for low-tech process-based restoration. So these types of permits and regulations and oversight are incredibly important to ensuring good quality work, especially in near infrastructure in highly engineered type of restoration. But for the type of work that we're doing, it's not highly impactful to the meadow. We're not using heavy equipment. It's you can easily go there and rip off some branches if you went a little too high on one, or you could make them higher. It's not the same. And so our agencies are recognizing that if we are working with the appropriate partners and we have a good practitioner that knows what they're doing and has experience, that we don't need to cover them in green tape and drag them down from proceeding with this important work. If the funding is there, oftentimes permitting and other types of green tape will hold us back from getting the work done. And sometimes it takes a long time and agencies are fighting and they're like, oh, you didn't cross the T's and dot the I's. And so it's going to be another 6 months because we're understaffed. So for this type of restoration, there's the Cutting the Green Tape initiative that is getting these permitting folks together and having them communicate and bringing them out and showing them what we're doing and showing them that when we're doing construction, we're adding such little amounts of sediment during the process. A lot of it has sod or other types of materials. We're not adding sediment. All these things, their concerns are mainly around sediment. And when you bring them out and show them what we're doing, those concerns dissolve. And so we're moving through permitting much quicker.
Awesome. Thank you so much for the answer.
I have one last question, and this is for Marcos. And I know we need to close, but just allow me. Marcos, do you think there's going to be some progression in topographic mapping that will indicate where you can have cell phone service?
So the answer to that is yes, that does exist. There's all types of terrain mapping through
Wow.
something called geographic information services, and as part of that, it's the ability to visually see geographically where certain things lie. Cell phone coverage is one of those. You can very easily find maps that will show you cell phone coverage spatially through these GIS or geographic information systems.
That was actually a facetious question, and I'm really surprised to know that you can get that information. Thank you.
That is impressive. I did not know that. Thank you. Well, do we have any more questions? I know we're a little long on time, but speak now or forever hold your peace as far as questions are concerned. And if you don't have any, you can and if any pop up later, you can always email someone on the California Environthon RAP committee or whatnot, and then they can reach out to Garrett or Marcos or someone else as far as getting a question answered. And I think they'll be more than glad and happy to answer a question later on. Oh, we may have got one more. Oh, it's just Garrett
It's
putting
just
his
me.
email in there for direct question contact.
Nice.
So I think, yeah, I think I've had everyone saying thank you, and thank you for being on, everybody, for today's California Environthon Beaver and Hydrology webinar, and have a great rest of your evening.